discussed what is acceleration, and we defined it as the rate of change of velocity of a moving object, and it has a particular direction. Acceleration is said to be positive when it is in the direction of velocity, and acceleration is said to be negative and it is opposite to the direction of velocity. So these were the concepts that we discussed. Again, we discussed the SI unit of acceleration, which is meter per second square. And if you remember, the formula for acceleration was A is equal to V minus U by T. A is equal to V minus U by T, where V is final velocity, U is initial velocity, and T is the time taken to that means time taken for the velocity to change from U to V for that moving object. Today we will discuss a very important concept that is central to the understanding of motion, okay, and that is our ability to represent motion of a body in terms of graphs, okay, in terms of graphs. So our topic today is graphical representation of motion. You can see graphical representation of motion. If you have to understand motion in physical terms or in physics, you have to have the ability to comprehend graphs. That means you should be able to understand what graphs convey to the reader or observer. If you don't know how to interpret graphs, then it will be very difficult for you to understand the concepts of motion. Now you see, the first question that may come to your mind is why we need graphs. Okay, why we need graphs. In fact, this question is very important to understand how to apply the ideas of graphs to describe motion. Now, what is a graph? What is a graph? Ask yourself this question if you know the answer to that. What is a graph? A graph is a visual representation of some data. Okay, so that means a graph is a visual representation of some data. Now for that we can have various types of graphs. I will not go into the details of the various types of graphs, but what we will do, we will focus our attention to mainly line graphs. Okay, suppose here is income, and this side we plot days: first, second day, third day, fourth day, fifth day, etc. This is just an example. This is, all of you have seen graph paper. Okay, now see what I have done here. I have selected two axes. This is the axis, one of the axis. This is the other axis. Okay, you have these ideas. This axis contains the label days. Okay, so this is basically the independent variable that we plot on the x-axis. This is known as independent variable. Independent variable. And on this side we plot dependent variable. Dependent variable. So what is important here is to note that for our discussions in this chapter, we will limit ourselves to this type of graphs only, where one variable will be plotted on one of the axes and the other variable will be plotted on the other axis. Okay? So in this example that I have given, the independent variable is the number of days. On the first day, suppose this is day, this is suppose income. On the first day, suppose he earns 50 rupees. Second day, suppose he earns 200 rupees. Third day, suppose he earns 250 rupees. So this is the set of data. This is the set of data that you have in quantitative form. That means what? In form of some numbers. In quantitative forms, you have the data here. Now, if you look at this data, then you have to think a little bit whether his income is increasing or decreasing. If you have to look here for some time, and then you have to analyze that data and say whether his income is increasing or decreasing with days. Okay, now let's plot this data on this graph. Let's see what happens. First day, 50 rupees. So from here to here it is 100. So 50 rupees means somewhere in the middle. This is a point that is corresponding to number of days 1, and corresponding data is 50. Why 50? Because this is the data set. Second day we have 200. That means the point is here. Third day is 250. So third day corresponds to this value 250, somewhere here. Now you see, if you try to join this curve like this with these points, what you see here, if this graph is given to you, you can see with the number of days this graph is going up. With increase in the number of days, the graph is going up. So this is a pictorial way or visual way of putting this quantitative data. Even if this quantitative data is not present now, but directly this graph is present, then you can see and say that what you will conclude, that his income is increasing. Just by looking at this graph, and checking these labels, you can say that with increase in the number of days, his income is increasing. So what is a graph? Graph is a pictorial way of representing quantitative data. Data that is given in the form of numbers can be expressed in visual way, so that it is easy to interpret the result. Okay, so that you can easily understand. Just by looking at the graph, you can understand what is happening. You can understand the physical situation just by looking at the graph. So this was about graph. But in physics or science, and particularly related to this chapter, there are some special graphs. Okay, there are some special graphs that we need to study. The first graph that we need to study is distance versus time graph. So first you check the level of the graph, distance versus time. That is the name of the graph, distance versus time. Okay, now here we may have two situations. Okay, let us go to the first situation. Case 1 or case A. If the body is moving with uniform speed. Suppose the body is moving with uniform speed, then what is the graph? So first, to plot such a graph, we need a set of data. I will construct a set of data. Okay, two columns I have created. Now, on the first side, suppose this side, let's plot time. T represents time. And on this side, let's use X to represent distance. When time is 0, the distance traversed, let it be 0. Let it be 0. When time is say 1 second, let the distance be say 5 meter. I am selecting the data so that I can show you the graph corresponding to uniform speed. Let it be 2 seconds. Let the distance then be 10 meter. So x is in meter and t is in second. Let us take one more point or one more set of data. T is 3 seconds. Let it be 15. I want to make it amply clear that this is a very special case. I am selecting it to show you a special type of graph. Okay. Each and every time, whatever experiment you are doing or whatever observations you are making, it is not necessary that you attain values uniformly like this. Now, first you have to select the variables. Which one is independent and which one is dependent. That choice you have to make. This is known as the origin of the coordinate system. This is the origin of the coordinate system. If possible, divide the axis into equal intervals. Do it according to your own convenience and your own scaling. Now let us try to plot the levels. In which side what we will plot? This side, on the independent variable axis side, let us plot t. T, it should be clear, it is time. And this side we are plotting x. Here x represents distance. Okay, here x represents distance. Now let us go for the first set of data. 0, 0. When x is 0, that means, when t is 0, x should be 0. So first come to the time axis, t is 0. X is also 0. That means this point. Second set of data. When t is 1, t is 1 means 1, 2, 3, 4, 5. Suppose this is 5, 10, 15, 20. T is equal to 1. 1 means this is t equal to 0, this is t equal to 1. Okay, this point is t equal to 1. Then on the x-axis you have to find 5 meter. T is equal to 1, not on the x-axis, on the distance axis. This distance axis you have to find, for t equal to 1 you have to find 5 meter. So t is 1, 5 meter means you have to go 5 meter upwards, this point. For 2 seconds you have to find 10. T equal to 2 seconds, 10 meter in upwards direction. Once again, t equal to 2 seconds, you find 2 here and then 10 go upwards. Why upwards? Because this is the distance axis. At t equal to 3 seconds, you have 15. So here is 3, you go for 15 here. So you see, you have one point corresponding to this set of data, second point corresponding to the second set of data, third point, this point corresponding to third set of data, fourth point corresponding to fourth set of data. And if you draw the graph properly, you will see that all these points seem to be on a straight line. So using a scale, we will draw a straight line that passes through all these 4 points. Okay. Now what is interesting to note here is that this straight line that you have drawn is the graph, and it passes through the origin of the coordinate system. It passes through this origin. Okay. So distance versus time graph for uniform speed is a straight line. So the statement you will write is distance versus time graph for an object. If there is an object which is in uniform, you can say uniform motion, then its distance versus time graph, distance versus time graph is always a straight line. Okay, is always a straight line. Now by coincidence here the straight line is passing through the origin. If we have taken t equal to 0 and originally suppose some distance has already been traveled, then we can put 5 meters here. In that case the graph will shift to some place like this. So this may also be a case. If the origin t equal to 0, that means initially there was some displacement already. Then if you draw the graph, then the graph will be somewhat like this. So this is about distance time graph for an object moving with uniform speed. Okay, remember this is a special case, uniform speed. The velocity is not changing. So in that case, if you plot distance on this axis, y-axis, distance on the vertical axis and time on the horizontal axis, what you get? You get a straight line. The straight line may sometimes pass through origin if the situation is like this. Otherwise, it may be like this also. Okay. There is one more case. In this particular heading, under this particular distance versus time graph, one more case we may have. Moving with non-uniform speed. Moving with non-uniform speed. Again, the main heading is distance versus time graph. Under that, in the last case we studied what? Uniform speed, if the object is in uniform speed. But what happens if the object is not in uniform speed? That means it is in non-uniform speed. Under that case, what will happen? Let's check. Again, let's select some points. For sake of simplicity, let the distance be 0 meter initially. In 1 second, let it be 5 meter. In second second, what is happening? Let the distance increase to say 15 meter. Distance has increased to 15 meter. And in the third second, it has become say 60 meter. So this is the set of data. Let us try to plot it and see what happens. Three, 4. So this is 0 time. 1 second, 2 second, 3 second, 4 second. This side we are plotting distance. Let it be 10, 20, 30, 40, 50. I'm running out of space. 60. So this side we have plotted distance. Remember the graph is for non-uniform speed. Okay, the graph is for non-uniform speed. Non-uniform speed. This side we have time, this side we have distance. So at t equal to 0, x equal to 0, so this is easy, this point. At t equal to 1 second, distance is 5 meter. So 1 second, distance is 5. The first division shows this is 10. So this will be 5. At 2 seconds it is 15. 2 seconds it has suddenly jumped to 15. That means here 15. But at the third second suddenly it jumps to 16. Okay. So what is important here? You will see that the graph is somewhat like this. Okay, the graph has become, or the graph has deviated away from a straight line. It is no longer a straight line. In case of non-uniform speed, the graph is no longer a straight line. Okay, it can be any type of curve. Now it is not necessary for the graph to go up like this also. If I have used some other values, say 10 say 25 meter, then it will be somewhere here. Okay, it is upon the selection of these values only. So in case of non-uniform speed, you will remember the graph will not be a straight line. Okay, the graph will not be a straight line. It may rise up like this. Okay, it will, if this value is say 25, then the graph will be somewhere here. Point will be like this. So I hope this is clear. Distance time graph in case of uniform speed is a straight line. Distance time graph in case of a body moving with uniform speed is a straight line. But in case of non-uniform speed, it is somewhat like this. Okay, increasing graph but not a straight line. Increasing graph but not a straight line. So in the next class we will discuss another important type of graph, and the name of that graph is velocity time graph. Again we will discuss uniform and non-uniform cases. Okay, till then what you will do, try to go through your NCERT textbook, and there is two constructed tables. From plot those graphs by taking help of the data in those tables. You will find the tables in the textbook. Use those data that are given in the table to plot your graph for distance and time. Okay, thank you.